This section 5.5 uses stuff that we already went over and kind of adds a little bit more to it. So the first thing we want to talk about is this word rates. So when they say using unit rates, rates we said was a ratio with different units. So where before, if we're talking like the teacher-student ratio, it's a certain number of people, teachers are people too, divided by a number of students. So it's people over people. So the units cancel out in a fraction. When you have a rate, it's going to be two things where the units don't cancel. So an example would be something like miles per hour, or frames per second, or cost per day, or something like that. So rate, basically the units are different in the top and bottom of a fraction. Good? Write it, don't write it? Write it. Okay, so we could say then, so rates are going to be ratios with different units. I can see where that wouldn't be incredibly clear, so I'll do an example. So example, I taught science for a bunch of years, so I think like miles per hour. You know, you could go through and say, John drove 500 miles in 3 hours. How fast was he going? Well, why not? So example, we could say, let me move my example thing over. So 500 miles in 3 hours. So 500 miles, 3 hours. That would be an example of a rate, because you have different units, numerator, denominator. Good? Now the new part, they add to that this like unit rate. So it's kind of like, what's a unit rate? So a unit rate is going to be the same sort of thing, but it needs to end up being a number divided by 1. So in other words, you could say we went 500 miles in 3 hours, or you could take and divide that, and wow, I should have picked numbers that would make a little bit more sense for a car. My car's not doing that. So what is it? 166?
166.
Yep. So then if we did that 500 divided by 3, that would be 166.6 repeating miles per hour. And that's going to be a unit rate, because it's kind of like the 166.6 repeating. You agree we could write that over 1 if we wanted to? And I don't know if that's really helpful, but you could say it's 166.6 miles in 1 hour, if you looked at it this way. But most often I think you're going to find that they just do the 166 miles per hour. Like that. Good? So you take a rate, you take a ratio, actually do the division, and then come up with just one number. That's your unit rate. So my notes really from here just consist of 3 examples, and then we're pretty much done. So example, let's probably call it 2, because we already did 1 example kind of. I'm going to say in a 40-hour week. So in a 40-hour work week, Butch makes, I did $380. So. And then from there you could say, what's his wage per hour, or what's his pay per hour? What's his pay per hour? And one word that, if this word per often shows up in story problems. When you see that word per, that means what math operation every single time? Divide by, or division. So when we say pay per hour, then you say, well, what's his pay? His pay is going to be the $380. Per means division, and then hours, well, he gets that in 40 hours. For a whopping total of, what was it? 9.5. So 9.5 would be the unit rate. If you wanted to, you could say that it's going to be $9.5 per hour. And you could also write it as the 9.5 as a fraction. Say, well, it's $9.5 in 1 hour, because it is a unit rate. Good? The book takes it one step further. And this part here might be a little bit rustier for people, but they say they want to change this into a rate formula. So I'm going to say rate formula. And this, I was trying to figure out, how do I put this into words? Well, we figured out his total pay was $380 when he worked 40 hours. We're kind of looking for an equation to say, well, how could you use this 9.5 to come up with his total pay? So I want to say his pay, I'm going to do capital P equals, how do you figure out how much he makes if he works 17 hours or 60 hours in a week? Go for it, Georgie.
P equals 388.
Not 380H, because then if he worked 1 hour, he'd make $380. 2 hours, he'd make double that. But it's going to be, do you see it? 9.5. So you take that unit rate, if you do 9.5, then you could do times T if you wanted to. I'm going to do times H because our time's in hours. But now that would fit the problem. So if he worked 2 hours, he'd make $19. If he worked 4 hours, it'd be 9.5 times 4. He'd make $38. Good? So when the book says find the rate formula, that's kind of where they're going with it. But those I thought were a little tougher than the other stuff in the section. All right, second example. Could say, Frank, it's all about you, my friend, makes $23 in 2 hours. And you could go on and say, well, does he make more than Butch, or what does Frank make per hour? So we'll say pay per hour, question mark. Kind of keep it short. So pay per hour. So when we see that per, that's going to be our division. And the pay is 23. The number of hours is 2. And then punch that in, we get 11.5. So he gets $11.5 per hour. So where Butch made 9.5, our friend Frank here makes 11.5. So if we wanted to change that into a rate formula for Frank, we'd say P equals, his pay equals 11.5 times H. So we have a new constant there. It's 11.5 times the number of hours. Safe to go on to my last example?
Could you just do 11.5H?
Yeah, yep. I just put the dot in for make it a little more clear. But yeah, I'd probably write 11.5H if you weren't watching me right now. My last example then, I'm going to say, so TVs. TVs show like the moving picture by basically doing a whole bunch of still shots on the screen, right? And that's going to be the refresh rate or the frame rate for a TV. So I'm going to say my TV displays 600 frames. So my TV shows 600 pictures in 5 seconds. And now if they go on and say, well, how long does it take to get 1 million frames? So how long to get 1 million frames? Notice, how long do I need to stare at my TV in order for it to flash 1 million pictures at me? Now there's a couple ways to do this. The first way is to do what we're doing in this section, kind of the unit rate thing. To say, well, if it's 600 frames in 5 seconds, how many frames per second is that going to be? So if I want to do frames per second, I do my 600 frames divided by 5 seconds. Already got to the end? So 600 frames in 5 seconds gives me 120 frames per second. So every 1 second, my TV flashes 120 pictures at me. Still good? Then we could take and change that into one of those equations and say, well, the number of frames equals what? So frames, if we want to get the number of frames, we would do 120 times maybe S for seconds or T for time. Does that make sense? If it's 1 second, it's going to be 120 times 1, 120 frames. If it's 2 seconds, it would be 240 times, 120 times 2. 3 seconds would be 120 times 3, 360 frames. Well, now from there, if I'm trying to figure out a million frames, I could put my million in for F, and I get 1 million equals 120 times S Now we can go back to what we've been doing for a while if we want to solve for s. 120 is connected to it by multiplication, so we divide. And I get the number of seconds it takes for my TV to flash 1,000,000 pictures at me would be 8,333.3 repeating if you wanted to seconds. And you could divide that by 60 to get minutes, divide it by 60 to get hours if you wanted to. But it'd be something like that. That's one way to do it. Here's a second way. Honestly, I like the second way more, but I can see where this first way is going to be better, especially if you need to do a whole bunch of questions. How long for 1,000,000 seconds? How long for 1,000,000,000 seconds? How long for 1,000,000,000,000 seconds? How long for, or frames? How long for 72 frames? Then it'd be nice to just have an equation like this, f equals 120s, especially if you take and solve that for s. But here's the other way. If you wanted to do it kind of in like more of one step, you could write it out this way. Our original ratio was 600 frames in 5 seconds. If you know that frames are in the numerator, you could put 1,000,000 in the numerator of a second fraction, change your ratio into a proportion, and have that there. And now just cross multiply. So you'd end up with 600x equals 5 times 1,000,000. So 5 times 1,000,000. So the right-hand side there is going to be 5,000,000. Divide 5,000,000 by 600, and you get that same 8,333.